Now that I got your attention, now that I got you thinking about something else, now I hit you with some math. So today we're going to be doing inequalities. So my friends, inequalities. In reality, it's no different. It's a little different, but no different than multi-step equations. It's the same in terms of the math, different in terms of little tricks here and there that you have to get familiar with. So I have an example right here that I'm about to draw out or write out. Oopsies, you weren't supposed to see that. So let's solve this right here, right now. 3x plus 2 equals 8. Can y'all tell me what needs to be moved? The 2. How do I move the 2?
You cancel it out.
You subtract the 2 to cancel it out and to subtract it from 8, leaving 3x equals, what's 8 minus 2?
6.
Tell me what I should do now.
You're going to divide the 3x and separate it from the x.
Leaving x equals, what's 6 divided by 3? 2. Boom, bang, bosh, done. That's what we did yesterday. Well, the basics of yesterday, right? Obviously, it could get a lot more complicated. Always remember you got to simplify each side before you start moving stuff. But the math of moving stuff from one side to the other is all the same. What if, my friends, if I go all the way back to the original problem, but instead of that equal sign, I am given this sign right here. This is no longer an equation. This, my friend, is an inequality. What is an inequality? An inequality is a mathematical statement that connects two unequal expressions. What does that mean? That just means if we were to solve this, well, I don't want to solve it just yet. Well, yeah, let's solve it. All in all, inequalities are no different than equations. You solve them almost as if it was an equation. You use the same exact math, except there's a little twist at the end, and there's a different meaning when you do get to the final answer. So if we were to solve this, what would we do? Well, we would do the same exact thing as before. We would split our worlds. We would simplify each side. Oh, there's nothing to simplify, so what do? We do what we've already done. We minus 2. 3x, 6, divide by 3, divide by 3. And just like that, that is my final answer. You do the same math, the exact same math as equations, except we have a different answer. This is a different meaning versus before. When we had the exact same problem but with an equal sign, (3x plus 2 equals 8). When we did the math, we came up with x equals 2. That's two different things here. In this problem, an equation, x is what? Well, x is 2. X is 2. X equals 2. There is no other answer except x being 2 to create this 8. The thing is, an inequality, all it is an expression. All it's saying is your x could be any number. It could be any number as long as it's less than 2. That's what that little sign means. Less than, greater than, less than or equal to, greater than or equal to, which I'll put up here, so don't worry. We'll get into more in depth on the symbols. But this, that's exactly what it means. If you were to put, tell me, Tell me, this 2 right here, what number is less than 2? 1. Okay, if we were to write a 1 is less than 2, is that statement true? Is 1 less than 2? Yeah. What's another number less than 2? 1.5, 1.9, 0, -1, -2, negative infinity, right? Negative 300. Is this statement true?
Yeah.
So it's not like you're really solving anything. You're really just bringing down your inequality down to its simplest term so that you could know the possible numbers of what x could be. Tell me, does it make sense to say x or 3 is less than 2? 3 is not less than 2. That is wrong. That's not a true statement. But we got to get into the why of things, even though I hate doing that. We got to get into the why of what do these inequality signs mean? How is this applied to into what sort of math and this and that? It all comes together right here. Let me find this picture that I want to show y'all. That is, if I could even find it. There it is. So there are my inequality signs. You probably learned this in elementary, the whole alligator trick. For instance, 5 is greater than x. Why is this sign greater? Well, the alligator eats up the big number all the time. So you could draw an alligator if you want. But I don't like teaching the alligator. You know what I like teaching? The dotted trick. Put a dot on each corner. And the side with the 2 dots is your greater side. So the way this is said, or not the way it's said, but the way it looks like is 5 is greater than any number, which means x could be any number less than 5. It works both ways. Look it. What could x be? Well, x is less than 5, so x could be anything less than 5. So that dotted trick could sometimes help you if you're kind of confused of what number should be greater than the other, or whether the letter is greater than or less than. This is less than just because of the way you say it, right? 5 is less than x, which means what? Throw a number. What could x be? What could x possibly be?
4.
If you put a 4 there, my friend, is 5 less than 4? Literally any number greater. 6. It could be 5.1. It could be 5.0001. Any number greater than 5. Because the way it's said is 5 is less than 6. What about this whole equals to and whatnot? Well, that's not complicated, my friends. If you have a little line underneath, that just means 5 is less than or equal to 6. You know what that means? That means your x could possibly be 5 or greater, which means it can be 5. But it can't be anything lower, anything less than 5, that's for sure. But because of this little line here, equal to, that means this unknown number, this x, could possibly be 5, 5.1, 5.2, 5.3, infinity, all the way up. That's what x could possibly be. This whole, what the number can be, all this and all that, that comes into play in a second. But first things first. We must learn how to get inequality problems. Oopsies, that's an equation. we must learn to get inequality problems down to its final inequality so we could at least guess what x could be. How would, well, we'll get to that. Let's do a couple problems. Like I said, it is no different than multi-step equations. That one is too simple. I want to redo this. I want to do okay. So here's my inequality. Like I said, there's no difference in terms of the math. Well, one little difference we'll get to. But for the most part, there is no difference between multi-step equations and inequalities. So, that being said, if you've mastered yesterday's multi-step equation problems, let's solve this. What's my step number 1? Build that wall at the inequality sign. Versus yesterday where we were building it on the equal sign. Look at each side. Is there anything to do on each side? Is there anything to do on this side, I should say? Negative 5 plus 3x? No. Move on to the next one. Is there anything I could do on this side?
No. Well,
Yeah.
yeah.
Distribute. 4 times 3x is what? That's correct. 4 times negative 8. What is it? Negative 32. Okay, this part, could it be simplified any more? No? Alright, so bring everything down. Oh, it's one of these. Do you remember what we called these ones? Our exchange, our little problem that we come across. I call it the Neil exchange. Y'all should call it your own name to help you remember. To help you remember these famous problems. We wanted to trade off some prisoners of war. So tell me, what do we want to move? We could move the negative 5? Okay, let's move the negative 5. By adding the 5, canceling it out, throwing it underneath its like term. But by default, what then needs to be moved? The 12x needs to be moved. That's part of our exchange. Cancels out, gets thrown over there. So now all our crossed ones are crossed. Let's solve what's left. Let's do this one. What's 3x minus 12x? Negative 9x. Less or greater than or equal to, and what's left over here? What's negative 32 plus 5? Say it. What is it? Nope. Did you say 37 or 27? Okay, you were right then. I thought I heard negative 37. Negative 27. So, my friends, what do we do here?
You got to separate the 9x from the x.
Yup. The 9, oopsies.
Divided.
The 9 wants to be over there with its other buddy, its other like term, which is the other number, which means you'd have to divide by negative 9 to cancel out and get thrown over there. And then x, I won't do the sign just yet. Tell me, what's negative 27 divided by negative 9? 3. All right, now, this is the one difference right here, my friends. As much as you would like to bring down the same inequality sign that you've been doing, down over here, there's this one little trick that you got to watch out for. If you ever resort if you ever resort to dividing, remember, dividing is always our last step, if you haven't noticed that. If you ever resort to dividing by a negative number, to leave the variable by itself, the one trick, this is the one difference between multi-step equations and inequalities. The one trick is you must by default flip your sign. That look of yours was priceless. So that's the one difference. That's the one difference. Only when you divide by negative. If we go back to our first example, this one, if you notice, let me erase this. If you notice, the inequality stayed the same on this example that we first did. It stayed the same throughout, all the way to our final answer. Reason being is because if you look here, all I did was divide by the 3. The 3 was in a negative, right? Only when you divide by a negative. No, it doesn't matter what your answer comes out to be, whether it comes out positive or negative. No, it doesn't matter if the original number that you were dividing to was a positive or negative. All that ever matters is if you have to detach a number from a variable via division, if that number is a negative, flip the sign. Clean cut, that's all. It does not matter what your final number comes out to be. It only matters if you resorted to dividing a negative by itself.
If it is a positive?
If this 9 was a positive and you divided by a positive, then the inequality stays the same. Only when you divide by a negative is when you flip the sign. So tell me, when do you flip the sign?
You divide by a negative.
Ooh, say that again?
You divide by a negative.
That sounds like the perfect answer to that. Hint, hint, wink, wink, if y'all are ready for tomorrow. Okay. So, do we get the overall idea? So, how will a problem look like? For those of you taking all these tests that exist in our world, how would a problem look like? How would a question look like? It's pretty straightforward. Let's pretend we have a couple multiple choice answers here. A, B, C, D. That was all wrong. So there's my multiple choice answers. And let's pretend all this math was not here. The question was the original problem. So, given the following options, which one could X possibly be? Hopefully you had the math that I just erased so that you had that final inequality that we had come up with. What was the final inequality that we had come up with? We did all this math. What was my final inequality?
Less than or equal to 3.
X is less than or equal to 3. So tell me, which one is it? C. Because of that equals to, right? Because of that equals to, yes, X could possibly be 3 or anything less. But that's the only option to choose from there. That's the only option.
What happens if there was a 2 up there?
What happens if there was a 2? Like this?
Yeah.
Well, in this specific example, there would be 2 answers. They won't give you 2 answers though to choose from. But yes, if I were to give you this on the quiz and be like, hey, hint, there is more than one answer, it'll be 2 and 3. But for most part, administrative tests, just like the WALMAP, just like the CASAS, just like the GED, you're always stuck with just one final answer.
So if they give you a multiple choice like that, will they give you the answer in the multiple choice?
Yeah.
Or the option of none of the above?
So now comes the final thing. My friends, why would we need to do all that? Why would we need to solve all of this to come up with the final inequality? Well, 2 reasons. To solve questions that look like this, right? They have multiple answers and they ask you which is the possible answer that X could be. So we would only know which one to choose if we had this final simplified inequality. But there's another question that might be given. That question looks like this. Don't lose this little inequality that we came up with. Remember it, because I'm going to make you tell me it, because I forget easily. One, two, three, four. -1, -2, -3, -4. So here's a number line, my friends. So if you don't know, sometimes, and in this specific day, this worksheet, all the time, you will be asked to not only solve the inequality, as in solve all of this to create that, not only will you have to solve the inequality, but then you would have to graph that final inequality. How do you graph inequalities? Let me show you. What was my inequality that we just came up with?
3.
Oh, X is less than or equal to 3, right? That was my final inequality from the last problem. So they not only did they want me to provide the final inequality, that was A. B, they now want me to graph that inequality. So how do I graph that inequality? Well, simple. You're given a number line. This is what you do. Well, first things first, let's practice our dots. There's this little thing called an open circle and a closed circle. Which one you use is dependent on what inequality sign you have. If you have a greater than or less than, you're going to use an open circle. If you have a greater than or equal to and less than or equal to, you're going to use a closed circle. Does it make sense so far? I'll explain that right now. But overall, in this inequality that I have right here, am I going to use an open circle or a closed circle?
Closed.
Closed, all right. So you at least know that for now. What you do is you place that closed circle in the number. 3. Where's 3 on the number line? Right there. So you put a closed circle. Now tell me, my friends, what direction we are going to actually shade. We are actually going to do this, or we're actually going to do this. We're actually going to shade the part, either to the left or to the right of that dot that you just put in. We are going to shade in the number that X could possibly be. What could X be?
The very end of the line.
Well, what number could X be?
Any of those numbers.
Any of those, right? It could be a 2, it could be a 1, it could be a 0, -1, it could be anything less than 3, which is why we shade in like this. And that right there, my friends, is how you graph inequalities. That's how you graph inequalities. Does that make sense?
We also write x to
This graph that we just drew shows whoever it is that looks at it what x is or can be. It tells them that, hey, x could be a 3 or anything less than it. The reason why they know it could be a 3 is because of that closed circle, right? So if we didn't have an inequality, this is going to be something that you're going to need to learn, my friends. Not only will you be given inequalities to solve and then graph, what they can do is give you a graph. They could give you a graph, a drawn out inequality graph, and what you got to do is write out the inequality. So you not only have to draw out graphs, you got to be able to read graphs. So this is the example we just did. Look at it. It is a closed circle. So you know it's going to be an equals to sign. And it doesn't really matter. You can literally do it any direction. You could do it the opposite way. It doesn't matter. You just got to make sure you put the number and the letter in the correct place. So, you know because of that closed circle that it's going to be an equals to sign. So now tell me, what's the number?
3.
Well, it's on the 3, right? Tell me, what could x possibly be?
4, 3.
Anything less than 3, right? Which means x must be less than 3, right? This, by the way, is no different than the one we had before, if you really look at it. But you're going to have to practice your skill of reading graphs and finding the inequality sign of it. Let's do a couple more examples. Well, actually, now that I just showed you this, let me give you a couple more examples. If I were to start drawing some random stuff. So I'm drawing you one right now. Tell me, who wants to give it a shot? Who wants to give me an inequality to this graph?
I can do it.
Give it to me.
Okay, so it would be x or whatever.
Mm-hmm.
Or actually, how about this? -2 is greater than x.
So you're saying x is with the inequality you just drew, or that you just said, you're saying -2 is greater than x, right?
Right.
So x could be anything, any number less than 2, -2, right? That's what you just told me.
More than
X could be any number greater than 2?
2.
If that is the case,
Greater
it should be like this.
Yeah.
That does match that graph. The one you just said before does not.
It was the opposite.
It was the opposite. There you're saying -2 is greater than x, which is the same as saying x is less than -2. And remember, the shaded part is where x could possibly, the number that x could possibly be. So, master that, and master reading graphs, and master drawing graphs, which I'll do another one. Let's say I just gave you an inequality of, actually let me try to trick you guys. This could creep up at any given time. -x is greater than or equal to 3. So, how do I graph this? Or what do I even have to do before graphing? A closed circle on 3.
Shaded into the left.
Shaded into the left. Does everybody agree with that? Shaded in to the left. The thing is, my friends, before you even draw anything, your inequality sign is not done.
Oh yeah, 'cause you gotta switch it.
Remember, you are never done, just like yesterday, until your variable is positive. Which means this inequality sign in reality, or this inequality, you should be able to divide by -1, divide by -1, leaving x is less than or equal to -3. Why that? Because I divided by a negative and it flipped the sign. Do you see that? Do you see the trickeries that this thing has? In order to get rid of the negative x, in order to get rid of the negative sign next to the variable, you divide it by -1 to cancel out, throw it over there, leaving a -3, but flipping the sign because you divided by a negative number. So guess what, my friends? X is less than or equal to -3. That's what we want to graph. So let's graph this. Where should I put my filled in circle or open circle? You tell me. Is it open or closed? Closed. Where at? On the -3. That's the big difference there. Now tell me, what could x possibly be? Well, x is less than -3, which means it must be any number less than 3. -3. -4, -5, -6, all of those are less than -3. That was the tricky one that I wanted to go over with you. Does anybody have any questions?
Steven does.
So let's do one last inequality problem. (5x plus 14 is greater than 2 plus 7x). All right, just like multi-step equations, there's no difference. So what's my step number 1?
Make your wall.
Is side A as simplified as possible? Is side B as simplified as possible? Yes, so guess what? We just immediately have to start moving stuff. Let's start moving stuff. What needs to be moved? Well, what do we want to move first?
5x.
Okay, 5x. How do I move the 5x?
Divide it.
No. Division is used to separate the number from the variable.
That's right.
If you want to move the whole thing, you must do the opposite of its sign. -5x. You minus 5x. Cancel it out. Gets thrown over. It's a like term. By default, then, what needs to be moved?
The 2.
How do I move the 2?
Cancel it out.
How?
And then you do a plus 2, put it on the other side.
You don't plus 2.
Oh,
You minus 2.
minus 2.
Leaving, what's 14 minus 2? 12 is greater than, what's left on this side? What's 7 minus 5? So tell me, what must I do? Divide by 2, cancels out. Tell me, my friends, what's 12 divided by 2? 6 is x. What sign do I use? Do I use the same or do I flip it? Same sign. Because I did not divide by a negative, you don't flip the sign. It stays the same. So you just solved this inequality and you left it as its final inequality form. But now comes the quick question. That inequality, 6 is greater than x. How do we graph it? 6 is greater than x.
Write in a 5 and a 6 on both sides.
Oh yeah, you're right. You didn't see that. Nobody saw anything. Oh, I just needed to add more here. Okay. So tell me, what do we do now?
Open circle on the 6.
Open circle on 6. I like the open circle. I like that it's on the 6. Now tell me, where should I shade in? To the left or to the right? Actually, show me, show of hands. Everybody has to lift up their hands. Should I shade in to the left? Or should I shade in to the right?
The right.
Nobody lifted up their hands. One more time. Raise your hand. Should I shade to the left or should I shade to the right? Everybody to the left. Show of hands. 1, 2. So, who votes for shading in to the right? 1, 2. No idea. 1, 2, 3, 4, 5, 6. So y'all, the unanimous decision votes for this one. Unanimous decision is wrong. X. Sorry, 6 is greater than X. By the way, if you didn't see the trick by now, the trick is to always say your inequality with saying the variable first. That's going to be the thing that kind of helps you. Think about it. This is said 6 is greater than X. All right, let's say you had to rephrase it, saying the X first. Let's say you have to say it. What would you say then? X is less than 6, right? That usually helps you because that tells you X is less than 6. So X could be any number less than 6, which means X could be any of these numbers here. Do y'all see that? Chances are that's going to be what makes or breaks you. That you shade in the wrong side. You'll do the math beautiful because it's no different than, except for that little flipping the sign trick, the math is the same as multi-step equation. The graphing part is going to be what gets you. You're going to accidentally shade in the wrong side. So my advice is always say, or always write out if you can, if it doesn't trip you up too much, always write your inequality with the variable first, which is the same as saying this. These are both the same exact things. But if it helps you to say the variable first, X is less than, or X is greater than, whatever, right? If you say it like that, it kind of helps knowing what X could be. It could be any number less than 6. That being said, my friends, I'm going to give out the worksheet. You are going to not only solve the inequality. I want to see my inequality. I want to see either or. It doesn't matter as long as you got this symbol correct. I want an inequality written on these on the side somewhere. And I also want that inequality graph on the given number line that they gave us. So have fun.